Is there a better way to store time-dependent data than add a valid from and valid to field to every record? We'll see. Hi, I'm Philip from codekabinett.com, and today I would like to build upon last week's video. Last week I published a video about time-dependent data, and I showed a very simple and easy way to implement time-dependent data in your database. You simply add a date from or valid from and valid to field to every record, and then you can define in which time range that record was valid or is valid. So, what's wrong with that? If you think about that, there is a slightly fuzzy feeling about this data not being normalized. Because if you store valid from and valid to in each record, you need to take care what you stored in the previous record so that you kind of do not include a gap in your data. Last week we had the example with prices, so there must not be a gap, because if there is a gap when the valid to date is not immediately taken to the next valid from date, then there's a gap where there is no price at all. Or even worse, if you don't pay attention and mix up the dates and your next valid from date is before the valid to date of the previous record, then there is a period where both records overlap, and that is ambiguous information, and that is something we don't like in databases at all. So I always had the fishy feeling that something is not right about this approach. And actually, doing a little bit research for this video, I came across a rule for that. There are rules of normalizations, and there is the first, second and third rules. These are the basic rules of normalization, and they should be in every database. And then there is the 3.5 rule, or named Boyce normal form. That is a normal form beyond the basic levels of normalization, and that is exactly addressing this issue. The Boyce normal form prohibits functional dependencies between multiple records in the database, and that is exactly what we have right here with the valid from and valid to dates, because the valid from date of this record depends on the valid to record of the other record, and that is a functional dependency. If I change one, I need to change the other, and I need to make sure that they both add up, that they are immediately adjacent or identical, depending on how I formulate the query. And now I would like to show you a way that is more normalized. This is the same database I used last week, so just a very quick introduction. It is some sort of inventory system for a grocery shop. There is a table TBL items, which contains the items the store sells. It's just mainly important today the ID and the item name. Then there is an order, and the important part is the order date. And of course there's a customer ID and order ID, but that are of minor importance today. And there's order position that links an order to an item, and it contains the quantity ordered, but that is of not too much importance. Last week I created a table TBL price, and this price table contains the prices, obviously. I just filter down to the records where the valid from and valid to dates are. If the valid from date is null, then that price was valid from the beginning of time, and if the valid to date is null, then this price is valid indefinitely, but you can easily enter a date to kind of end the validity of the price. So here you see this price. Oh, let's filter down to one single item so that you can see it better. So this price was valid till end of December 2018, and then here is a new price that was valid from beginning of January till the 15th of January, and then here is a new price from the 16th of January. So they are neatly lined up, immediately adjacent to each other. So these are queried in this query, and please pay attention to this record, to this order that was ordered on the 16th of January. So we close the query and go back to the price table, and now I change the record here. I made a mistake. I needed to pay attention to the 15th and then add a new price at the 16th. I made a mistake, added it at the 17th, and now I run this query and you see the record. There's only one record left for that order on the 16th, but the other record has gone missing because this query assumes there will always be a price for an item we sell, so it uses an inner join to query that table, and the record where I mistakenly entered the wrong date just a minute ago, that vanished because for the 16th of January there is no valid price. And the other way around, if I accidentally enter the 14th of January here and run that query again, then you see the even worse case here. This is one order and one item, and it was ordered on the 15th, and you see here at the end there are two different prices for the same item at the same time. That is something that is confusing and outright wrong. That should never happen because it will confuse everybody seeing this. So we are going to address this issue now. So let me just fix the price that is correct. And now the first thing we do is open our price table in Design View, and we get rid of the valid to field altogether. Yes, we delete the data, it is gone. I save the table, and here we are. So with the previous approach, null values indicated that a price had been valid from the earliest date possible. That is something that we cannot continue to use. So I'm going to create a very quick query here on the price table, and I will update this the price, and we will enter the earliest price for all records where there is currently null. And I just assume we started the business on 1st of January 2015, and we will enter this in all records where there is no value, where the price is, the valid from is null. So we're going to update 15 rows, fine, I don't need this query anymore, and now there is a valid from date in this query. And while we were talking about normalization, this is not essential, but the price ID column was a surrogate key. Artificial key, just an auto number to identify the price, and that was required because there are multiple prices per item. That is our intention. But I'm not a huge fan of artificial keys, and now we can actually get rid of that key just switch to design view. We do not need the price ID key anymore at all. Yeah, delete the primary key, please. And now we move the fields around and create a new primary key, and it will be a composite key, a key consisting of two fields, and it's item ID, the identifier of the item, and valid from the date. And now we can store that. That is one of the reasons why there cannot be null values anymore in the valid from column. I just switched that around if you are wondering why the order of columns is different. So we still got the prices here. And now it's pretty simple. I would just cut that down to one item to make it clearer. When we opened our business on January 2015, the item was priced to 30. And then we changed the price on the 1st of January 2019 to 290. And obviously, the moment we entered the new price, the old price became invalid, or rather not currently valid. And the same happens here on the 15th of January. There is a new price once again, and the old price becomes invalid or deprecated. And there's only one field. When I want to enter a new price here, then I would just do that. I enter a new record and say now it's 380 of, don't want to exaggerate, 380 here. So I just need to enter this for a new price, and there is no dependency to the previous record. So now let's try to query this new price structure. This is the query we used before. It will not work anymore because we deleted a column that was required there, but luckily it still has the SQL here. Now the basic thing up here, this join condition on the price, that will stay as it was, no change there. Now the valid to field was deleted, so we can get rid of these two lines, and we changed valid from in TBL price that it does not allow null values anymore. So our or is null condition is obsolete as well. Now this one here, that is still valid. Of course, we only want to join the price that has become current on the order date or before the order date. But I will move that around a bit. I will just swap the order of columns, and then I obviously need to query for less or equal order date. The price valid from is less or equal order date. And now we need another condition. And I'm going to write it with a correlated subquery, and I think there is no other option to write this type of query. So I will explain that in a minute. Or let's do that quicker. I'm not going to type it, so I will just format it a little bit nicer so that thing becomes more obvious, and I'll explain it in a second. So here we are. Generally, the exists or not exists operator, they just check, is there any record matching this criteria? And if the subquery here returns a record, then the exist would be true. Or if we invert it, this subquery must not return a record for the top expression, the exist expression here, be true. So let's look at the subquery. This select X, that is just a constant. As I said, the exist operator only checks is there any record. It does not evaluate any data in that record, so we don't need any data. And to make this clear, I just usually write select X as a constant. You could use a numerical constant like select 0, or you could actually use an item from a column from that table, or you could also use the star. It's all the same. That is my personal convention. I write select X, but it doesn't make any difference what you exactly write there. So the important thing here is that is the TBL price, and there is the TBL price as well. So we added this table twice to our query, and for that reason we absolutely need this alias. That tells the query engine we will refer to this TBL price with the term P2. So I overwrite that. That is the table price here, and that is referenced here and referenced here, and it is referenced down here and up here. And our P2 table, that is this one here. So that are essentially two different tables. They contain the same data, but in the context of this query, that could be two different tables, and to distinguish them, we need the P2 alias to make it clear which of the two TBL prices should be referenced now. For that reason, this alias is absolutely required here. Now let's look at the criteria. We've got this one here, and that is the same as in the join condition here, and we have this comparison to the order date here that is basically the same as here, and the really tricky part is this one highlighted in yellow, and that is something that makes my brain twist a little bit. So what we do, we query we query the same here as we did above, but then, and that is the important part, we check that there is no other price in the table price above that references this table price and compares it to the P2 table. We will get the latest record that is before the order date. So it essentially says there is no later record that is also before the order date than the one we queried above here with the table price. So we will always get the latest valid record. And that works quite nicely because we can now run this query and it will all work. You see, so I just filtered that down to only one record, and you see there is one price here, another price there, and yet another price down here. Oh, hang on a second. So you see, I changed the prices, the valid from date. That was supposed to be the 16th, and I just can change this single record, close the price table, and rerun my query here. We're going to look at that. And now you see we narrow that down once again to this record, and now you see, as I intended, there's one price here. Oh, let's use the yellow marker. One price here, another price there, and finally a third price here. And these are the prices according to our pricing table. So you see, these are exactly the prices we defined here for the different time frames. So as a conclusion, let's look at our query in design view. So this is a bit of a pain. It does work. You can look at this query in design view, and we need to move a little bit over here to see our condition. And you see the whole subquery, and well, you don't see it because it's multi-line. I can just scroll here, quickly open a notepad and paste it there. That is our expression from the subquery, and it's all moved up here into the expression text box here. And the nasty thing is when we switch back to SQL view, you see it is slightly changed. Access has changed that to exists. Now the expression exactly as we wrote it, but equals false. That is not exists, but exists equals false. That is something that is proprietary to the jet engine. No other database will understand that. And actually I very, very much dislike that. So I would once again recommend writing these queries in a text editor, and if possible store it somewhere as a text file that you are not dependent on Access for storing it, because Access will mess it up. And if you have to change this query later, I find it quite hard to do it if it has been reformatted that way. But anyway, it works, and you can still see what is going on here. So it's not too bad actually. So it is not that difficult, isn't it? But it has a slight drawback, this approach, because it's not as easy to display the data for the user. Of course, you can query the data and stuff, but it is a little bit more complex. The query is a little bit more complex. You need to carefully think about your query. And so this is definitely the better approach to time-based data, but it is a little bit more complicated. And I used the more simple approach over and over again. And I used this approach, the one I showed you today, the normalized approach with just one date column. I used that too quite a lot. But I always had the experience, if I just use a simple access form and just display the valid from date or whatever date it is, then users would be kind of unsure what they would make of that. You can explain it and you could display the other record, but it is additional effort, of course. So the choice is yours, which approach you like better, which you want to implement in your database. I showed you both, and yeah, I hope you liked these videos. If you did, then hit the subscribe button down there and like the video, please. Thank you for watching. Bye bye.